Let's take a look at an exemplar of the friction lab. Here's the original sheet that was passed out, the procedure sheet. It's got all the information on how to do the lab. We have our section of calculations and discussion, possible sources of error, there's the questions in there that we definitely have to be answering, and conclusion. And then these would be the data tables that you had done in class. So here's an example. This was a piece of student work which I took the front sheet off because it had their names on it, so I just very quickly wrote in the name and pen. Purpose is here, equipment is here, procedure, refer to attached sheet, make sure that that's there, and we look down at some of the results and observations. So here is one of their tables. Even before it was scanned, this was a little bit difficult to see. The table is a little bit on the small side, and even just by looking, the distance of the margin is quite large. So in order to maximize, you've got all this empty space here and all this empty space over here. Recommend using better margins. We scroll down, bit of a big space at the top here. We've got another graph, which again is a little bit hard to see here. It's difficult to read because the graphs were a little bit too small. So there's our graphs. They're all labeled, which is good. Another one which is labeled, and they're all there. Scroll down. All forces are measured in newtons. This is the data from the lab, which you had handwritten and you need to include in good. So this is typed up and put into the lab. So all of the data is presented. It's labeled nicely. And then we get into the calculations. So for the calculations, you need to include yourself a free body diagram. In this case, they've done it by hand, which is okay. It's not the best simply because handwriting is not quite as neat. I think sometimes when people do these, they think they're saving time by doing it by hand. In the long run, it actually takes more time because you have to redraw this every single time. If you had taken this first diagram and done it on the computer, then it'd be very easy to simply change over the numbers when there's a different force and do a quick cut and paste. So anyway, that's the comment about the diagrams. Here are the mu static, very nicely laid out. You've got FFS over FN, put the numbers in, very easy to see, and there's a calculation for mu K. And this student carries that through all of the calculations, so very nicely done. They've gone to 3 sig digs, because that's what our final answer should be going to. And again, here's the next free body diagram. Kind of a bit of a weird thing. You've got a space here, big space. They've shown all the calculations. Here's the next set. So they've used a method which is good. Then they have, as the lab requested, taken and put in all of the mu values into a chart. It's much easier to see all of these values when they're compared side by side as opposed to scrolling through 1, 2, 3 pages of calculations. Okay, it's very difficult to compare this mu value to the mu value that's on the next page, which is there, and then there's another one on the next page. Put in a chart. Now you've got all of these values right here together, and then when you start answering these questions, you can look at the chart. Remember, always go back to, here's the original sheet. Calculate FG for each trial. Calculate the coefficient of friction between each pair of surfaces using the average value. Show your calculations. Draw free body diagrams for each trial. Present the data that shows, in a table, that shows average frictional forces and coefficients. Then the questions, which is higher, static or kinetic? Discuss reasons why. Study the surfaces which had larger coefficients of friction. Comment on the statement, and there's a statement here. Okay, so comment on that. And explain how lubricants like oil can lower the coefficient of friction. You need to answer all of those questions. Discuss some possible sources of error in the lab and improvements that could be made to reduce the errors. You need to answer that question. Conclusion. You need to answer this conclusion. Okay, this is extremely important. You can't just ignore it. This lab did not have rough work. It did not have the lab sheet. So it is missing a couple of vital pieces of information. The layout of most of this is good, but they were missing a few key items.